When you're building for the web, there are really two big forces you're always dealing with. There's the creative spark that builds amazing things, and then there's this other force, the one that's always trying to tear it all down. Today, we're diving deep into this constant tug of war between the builder and the breaker. So what really separates a good developer from a truly great one? It's a question we all ask ourselves, right? Is it just about writing the cleanest code, shipping features faster than anyone else? Well, we think there's more to it. The real secret is understanding not just how to build, but also how things get broken. It's about having both mindsets at once. So on one side, you've got the builder. And let's be real, that's probably you. Your world is all about craftsmanship, performance, and making things that just work. Things that are fast, reliable, and make users happy. But then on the other side, you've got the breaker. Their goal is the complete opposite. They're hunting for loopholes, for any crack in the armor they can exploit. A great developer, well, they know how to think like both. Okay, so if we're going to build things that last, we have to start with the basics. We have to learn how to defend our work. Let's talk about the first line of defense, securing the digital gates to your application. First up, something you literally see every single day, HTTPS. The easiest way to think about this is that old school HTTP is like sending a postcard. Anyone who gets their hands on it along the way can read the whole message. HTTPS, though, that's like putting your message inside a locked, armored briefcase. It uses encryption to scramble the data, making it totally useless to anyone who might be snooping. It is the absolute, non-negotiable starting point for web security. Next up is CORS, which stands for Cross-Origin Resource Sharing. Now, the best way to think about this is to picture CORS as the bouncer for your app's API. It stands at the door, and for every request that comes from a different website, it checks the ID. It uses these special signals called HTTP headers for your server to tell the browser, yeah, they're cool, let them in, or nope, not on the list, turn them away.
So why do we even need a bouncer in the first place? Well, it all comes down to this core security rule that browsers have baked right in. It's called the same origin policy. And by default, it's super strict. It says a web page from, say, myawesomesite.com is absolutely not allowed to make requests and read data from another site like yourprivatebank.com. It's what stops a sketchy site in one tab from quietly stealing your info from another.
Let's break this down with a real example, because this is where it gets really clear. The browser cares about three things: the protocol, the host, and the port. If our original page is at http://www.xyz.com/1234, then any request to a URL with those exact same three parts gets a green light. But watch this. Change the protocol from HTTP to HTTPS, and denied. Change the host from XYZ to ABC, denied. Just change the port number, still denied. All three have to be a perfect match. All right, we've got our builder's hard hat on. Now it's time to swap it for the breaker's hoodie. To really defend our work, we have to understand the enemy. And the good news is, breakers aren't just making things up. They have a playbook, and a lot of their best moves are tracked by the Open Web Application Security Project, or OWASP. Let's talk about a classic, and I mean classic, and super dangerous attack: SQL injection. Now, what's really important to get here is that the breaker isn't hacking your database directly. No, they're much cleverer than that. They're tricking your own application into doing the dirty work for them by feeding it malicious database commands through normal input fields. And what's scary is just how simple the process can be. The breaker's thinking goes something like this. First, find anywhere the user can type something in: a login form, a search box, anything. Second, instead of typing a username, they type a little piece of SQL code. This tiny fragment is designed to completely change the meaning of your original database query, tricking it into doing something it was never supposed to do, like skipping a password check or just handing over all of its secrets. And this right here, is the golden ticket, the most infamous little piece of code in the SQL injection playbook. When a breaker sneaks this into a password field, they're basically telling the database, hey, I know you were about to check the password, but how about you also check if 1 equals 1, which is, of course, always true. The little dashes at the end then tell the database to just ignore whatever came after, like, the actual password check. And just like that, they're in. Okay, moving on to another huge threat in the breaker's arsenal: cross-site scripting, or XSS. Now, with this one, the target isn't your database, it's your users. The whole game here is to find a way to inject malicious JavaScript into your website.
Then, when some poor, unsuspecting user visits that page, the script runs in their browser. From there, it can do all sorts of nasty stuff, like steal their login info or secretly act on their behalf. Now, XSS isn't just one thing. It really comes in two main flavors. First, you've got reflected XSS. That's usually when the bad script is hidden inside a link that a breaker tricks someone into clicking. The script gets sent to your server and is immediately reflected back and runs in that one user's browser. But then there's stored XSS, and this one is way more dangerous. This is where the breaker manages to save their script in your database, maybe in a comment section or a user profile. Now every single person who views that page gets hit with a malicious script. Okay, breaker's hoodie off, builder's hat back on. Because a great app isn't just secure, right? It's gotta be fast. Like blazing fast. This isn't just a nice to have, it's a fundamental part of the craft. So let's look at a few key ways to make your applications fly. First up, let's talk about code splitting. So picture all your JavaScript as one giant, heavy box. The old way was to make every user download that entire box before they could do anything. With code splitting, we get smart. We break that big box up into lots of smaller, more manageable packages. The user only downloads the absolute essentials to see the first page, and then we grab the other pieces only when they're actually needed.
Okay, so we've split our code into smaller boxes. How can we make those boxes even lighter? Minification. The code we write is full of comments, spaces, and long variable names to make it easy for us humans to read, but the browser, it couldn't care less. Minification is a process that just strips all that extra stuff out, leaving a much smaller, denser file that downloads way, way faster. And for our third trick, we've got lazy loading. This one is just brilliant, especially for pages with tons of images. The idea is so simple. Why make the user download all 20 images on a page if they can only see the first two? With lazy loading, we only load what's visible. Then, as the user scrolls, we load the next images right before they appear on screen. And the best part? Modern web development has made this ridiculously easy. For images, in many cases, all you have to do is add this one little attribute to your image tag, loading equals lazy. Seriously, that's it. The browser does all the heavy lifting for you. It's a huge performance win for almost zero effort. So why do we go through all this trouble? Why does this stuff matter so much? Well, the payoff is absolutely huge. You get faster load times, smaller downloads, and your code gets processed quicker by the browser. It all adds up to a massively better user experience. And for anyone on a shaky connection or a limited data plan, it's the difference between an app they love and an app they close immediately. So we've spent our time looking at these two different worlds, right? The builder, who's all about creation and speed, and the breaker, who's focused on finding the cracks. The last and most important step is to bring those two worlds together. And this, right here, is the key takeaway. A great developer isn't just a builder or a defender. They're both. You have to be able to dream up and create amazing features like a builder, but you also have to look at your own work with a skeptical eye of a breaker, always asking, okay, how could someone abuse this? You know, when you start thinking that way, it fundamentally changes everything. Security stops being just another feature on the list. And performance isn't something you try to tack on at the end if you have some extra time. No, they become the very foundation that everything else is built on. They are quality. And that really brings us to the final question you've got to ask yourself. The bad guys, the breakers, their playbook is changing every single day. They're always finding new attacks, new tricks. So the real question is, are you? Is your toolkit as a builder evolving to keep up? Because that constant learning, that's what being a modern developer is all about.